Hello, Algebra with Finance students. Thanks for watching the recording for Unit 4, Lesson 6, Exponential Growth and Decay. First of all, you need to know what exponential growth and decay means. These function measure elements that either increase or decrease over time. So if it's an increasing or growth exponential function, as you're moving across the x-axis, as the x values get larger and larger, the y values increase as well, okay? That is an increase or a growth. A decrease or decay is when, as you're moving across the x-axis, as the x values get larger and larger, your function or the y values or the function decreases. Okay, so the first one here is an exponential growth function, and the second one here is decay. Okay, let's talk a little more specifically about what exponential growth means, and hopefully this will give you a little idea. So in an exponential growth function, it starts off very slowly and then it just explodes and gets larger and larger very fast. So for example, let's say this is you. You have the flu. You give the flu to your brother and sister. Your brother and sister then give the flu to 2 other people. So now 4 people have it. Those 4 people each infect 2 more people and so on. So starting with you having the flu, look how fastly it grows. This is called an exponential growth function. And then on the other hand, decay, let's say you're starting with a piece of paper and I tell you to cut this piece of paper in half. So now you have 2 pieces. Then I tell you to cut those 2 pieces in half again. So look, now you have 4 pieces. I tell you to cut all 4 of those pieces in half again, and look, now you have 8. Okay, so that means this is a decay because your pieces of paper get smaller and smaller and smaller as the time goes on. Exponential decay. Okay, write this down, please. You need to know the formulas for growth and decay. So your formula for an exponential function is f of x equals a times b to the second power. So I will write it a different way for you just so you could see it. It's a b squared. Okay, so your f, your function, okay? So it's a growth when your a value is larger than 0 and your b value is larger than 1. Once you see that, then you know that it's a growth function. However, if your b value is in between 0 and 1, then it is a decay. So if you also see these terms as you're going on, if you see the term appreciate, that is a growth function, and depreciate is a decay function. So let's just try one of these. Okay, if you're looking at this function, the function equals 2 to the x. Your b value is always to the base of your exponent. Okay, so here's your exponent x. Here's your base. Your base here is 2. So is this a growth or a decay? Well, I would say my b value is bigger than 1, so this first one has to be a growth. Then when you look at this one, my a value is 3, my b value is 1/2. So that means my b value has to be 1/2 is in between 0 and 1. So that means it's a decay. So let's try a few more. Hopefully you guys could look at this page. I want you to determine if each one is a growth function or decay function. And you could pause this video right now and come back to check your answers. So the first one, y equals 3 times 4 to the x. 4 is larger than 1. Your b value is larger than 1, so it's a growth. Number 2, your b value 1/4 is in between 0 and 1, so this is a decay. This one, your b value 0.87, again, is between 0 and 1, so it's a decay. And lastly, 1.8, our B value is larger than 1, so it's a growth function. So you need to know when a function is a growth and when it is a decay. Okay, compound interest. Okay, in compound interest, if you're putting money in the bank and it's being compounded, let's say monthly or yearly or whatever, and you're talking about how much money you have when you take it out of the bank, this is a growth function. And notice when you're adding money to your account, it's always 1 plus because you're adding money. So I would write down this equation here. You do need to know that, or take a screenshot of this page even. You have to know what all the parts of them mean. So your P is the original principal, how much money you're putting in the bank to start with. R is your interest rate, and your interest rate always has to be written as a decimal. So when you're given the interest rate as a percent, you need to change it to a decimal, and we'll talk about that in a second. Your N is the number of times it's compounded in 1 year. And I just put a little chart here. If it says it's compounded annually, that means once a year. Semi-annually, twice a year. Quarterly, 4 times a year. Monthly, there's 12 months in a year. They could say daily. If they said daily, it would be 365 times in a year. Okay, so that's what our N value represents. T is the number of years that it's sitting in the bank. And A is how much money you will have when it is all done and you take the money out. Note here, growth, appreciate, gain. These are all terms that would tell you that is a growth function. Okay, so let's do an example here. You have, she deposits $1,500 in an account that earned 8% interest, compounded semi-annually. How much money will Anitra have at the end of 5 years? So I know that it is a growth function because you're having interest added to your account. So we're going to use this formula here. So let's go through and define our variables. Remember, our A value is how much money you're going to have at the end, our final value. We don't know that yet. Our P value is how much money we are starting with. Well, it says she deposited $1,500 initially, so that is our P value. R is our interest rate, and we see here it says 8%. But you need to note here that you always have to convert your percent to a decimal. And by doing that, you take that 8 and you divide it by 100, and that will turn it into a decimal. That's how I got 0.08. N is how many times it's compounded in 1 year. It says here semi-annually, so that means twice in a year. And T means how many years you are keeping it in the bank, and in this case, it is 5. Once you make this chart here, it's very easy to plug into my formula. So here's my formula that I'm starting with, and I just want you to see if I take all the values we just talked about, and we're going to plug it into the formula. P is 1,500, R is 0.08, N is 2, and then here our exponent is N times T. So N is 2, T is 5, okay? When you plug this into your calculator, I want you to do, actually divide this first, 0.08 divided by 2. That's how I got 0.04. So we're doing it step by step here. 2 times 5 is 10. Then you could do what is inside the parentheses. Okay, so 1.04. Then in your calculator, you're going to do 1.04 to the 10th power. You get this answer. And finally, you multiply it by your principal. So that means at the end, I will have $22,220 in the bank. Okay. Exponential decay. Remember, decay, decline, depreciate, loss. These means you're losing, it's going down. So notice here, it will be 1 minus because it's decreasing. Here's our formula here. You can take a screenshot of this. A is our final amount, C is the initial amount, R is the rate of decay, and T represents time. So for example, you bought a new car for $25,000. What will the car be worth at 5 years after if the price of the car is depreciating 15% per year? So again, my A value is the final value of the car after 5 years. We don't know that yet. C is our initial amount, which the car was $25,000. R is how much it's depreciating. Again, you have to take that 15%, turn it into a decimal. So take 15 divided by 100. It'll give you your decimal. And T is how many years. So all you're doing here is plugging it now into the formula. Okay, so we have that. C is 2,500. You're plugging everything in. You're going to do what is inside the parentheses first. So 1 minus 0.15. Okay. Then you're going to do your exponent, 0.85 to the 5th power. And finally, you're going to multiply those out. That means after 5 years, the car will be worth $11,000. Kind of stinks, doesn't it? Okay, let's try another example here. Ronaldo deposits $1,200 in an account that earns 5% interest, compounded quarterly. How much will Ronaldo have in his account at the end of 3 years? You first need to decide, is this a growth? Am I adding money, or is it a decay? Well, since we have, we're adding interest, we know it is a growth. So there's our formula there. Okay. So remember, if it's a growth function, you are going to write down exactly what all these values mean. Our original principal, our interest rate, everything we talked about before. So if you look here, hopefully you're doing this at home and pausing it. I want you to look back and find that our principal, we're starting with $1,200. Our interest rate was 5%, but turning that into a decimal is 0.05. It's compounded quarterly. That means 4 times a year, and we'll be in for 3 years. Finally, you're just plugging this in, remember, to the formula. Here's our formula. I plugged all of my values in. You're going to do 0.05 divided by 4 first, and 4 times 3 is 12. Then you do what is inside the parentheses, 1 plus 0.0125. You get that? You take inside the parentheses to the 12th power, and you get that. And finally, you just multiply. So that means you'll have $1,392 in the bank after the 3 years. Okay? And lastly, I want to do another one. Ethiopia's population is 50 million, and it's been declining at a rate of 6% per year. If the population continues declining at this rate, what will the population be in 5 years? Again, ask yourself, is it a growth or decay? Because we know it's declining, we know it's going to be a decay. So you have your formula written down. And then remember, we have to write down all the values, what we know, okay? So if I look first, my C value, my initial amount is 50 million. It's declining at 6% per year, so 6 divided by 100 is 0.06. And we want to know how much it will be worth in what the population will be in 5 years. You're just taking these values now and you're plugging it in. All you're doing is plug it into the equation there, okay? So I plugged in my C value, my R value, and my T value. Remember, you do what's inside the parentheses first, 1 minus 0.06. You take that 0.94 and you raise it to the 5th power, you'll get that. And finally, you multiply. So there would be the population in 5 years. If you have any questions at all, please reach out to your teacher so we could help you. And thanks for listening.